Number 6, consider the parametric curve. C of t is equal to r cosine t minus r sine t. T is between pi and 2 pi. We're supposed to use methods from chapter 11 to find the surface area of the sphere generated by rotating the curve around the x-axis, and we should know what the answer is going to be. Okay, so let's start off by drawing a picture here to see what is going on. So let's just plug in points in here to figure out what this looks like. It's going to be a part of a circle, but the bounds are a little bit different than usual, and usually we're used to that being a plus here rather than a minus here, so we just want to be careful. So C of pi is equal to r times cosine of pi. Cosine of pi is -1, so minus r. Minus r sine pi. Sine pi is 0. So C of pi is minus r, 0. C of 2 pi is going to equal cosine of 2 pi is 1. R times 1 is r. And sine of 2 pi is again 0. So here is C of 2 pi over here. Now, we can basically see at this point it's going to go like this or like this. Let's check 3 pi over 2 to see which way it goes. Now, cosine of 3 pi over 2 is 0. R times 0 is 0. Sine of 3 pi over 2 is -1. -1 times minus r is plus r. So here, up here, is C of 3 pi over 2. So we can see at this point our parametrization is going in that direction. So we're used to, we're used to having this be our standard parameterizations, r cosine t, r sine of t. So this is making it run backwards, but that shouldn't bother us. We're going to need our surface area formula. Let me copy that down for us. So surface area is equal to 2 pi times the integral from a to b of y of t times the square root of x prime of t squared plus y prime of t squared dt. So what is this the surface area of? We're assuming that y of t is always greater than or equal to 0. It is. We drew that picture to check that. X of t is an increasing function. It is, in that case, r cosine t is increasing from pi to 2 pi. So this is all checking out. Y prime of t, x prime of t are both continuous. We're going to revolve this semicircle, going to revolve it around the x-axis, and that's going to give us a sphere, and here's the surface area of the sphere. So let's start plopping in everything. X prime of t is equal to minus r sine t. Y prime of t is equal to minus r cosine t. X prime of t squared plus y prime of t squared is minus r sine t squared plus minus r cosine t squared. R squared sine squared t plus r squared cosine squared t. And that's just r squared. So what do we have at this point? We have 2 pi times the integral from pi to 2 pi. Y of t is minus r sine t. And then times the square root of r squared, and that's just going to be r. We're assuming r is a positive constant, so we don't have to worry about square roots and absolute values and stuff like that. So let's see, what do we have here? We have 2 pi times r squared. The antiderivative of negative sine of t is cosine t. Plug in pi and 2 pi. And 2 pi r squared times cosine of 2 pi is 1. Cosine of pi is minus 1. So this ends up as 4 pi r squared, which is exactly what we should know that the surface area of our sphere is. Okay, so straightforward application of this formula here, doing lots of crunching out stuff. Make sure you understand what's going on with this picture over here.